So this is BOYS gas calorimeter. With the help of this instrumental setup, we can find out the calorific value of the gases. Now let us look into the setup of this BOYS gas calorimeter. So you have been having the gas tank. So in whichever the gases you have been filled it, so you can find out the calorific value of that respective gas. And here you can see that in this setup you are going to have the gas flow rate chuck meter. So this is the gas flow rate chuck meter, means at what rate the gas is being made to flow. And you have been having the pressure gauge, means at which the gas is being pressurized. And you have been having the water flow rate to find out what is the flow rate of the water. And you have been having a temperature knob. So here the temperature knob, so at point 1 it is going to find out the temperature of water inlet. At point 2 water outlet temperature we can find it out. At point 3 gas inlet we can find it out. Point 4 exhaust gases we can find it out. And here we are going to have a gas chamber where you are made to burn the gases here, and here you are going to have a water coil inside it. Now let us understand this theoretical part. This method is based on heat transfer by burning known quantity of gaseous fuel for heating the known quantity of water that circulates in the copper coil heat exchanger, which is built in. The heat transfer takes place essentially by the counterflow heat exchanger between the burning gases and circulating the water, so that nearly complete heat exchanger take place. Therefore, by above assumption that heat absorbed by circulating water is equal to heat released by burning gaseous fuel. Now you can see that double walled stainless steel outer chamber, thickly insulated within a glass wool in an annulus place. It is fitted to chimney to lead the burnt gases to copper shell. So it acts like a heat exchanger. The double pass copper coil assembly fixed to the copper shells. The top of the shells is fixed with a wooden cover for preventing the heat losses from the top, and it has been number of spouts for the exhaust outburnt gases. The base is housed with a burner, a direct reading of gas flow meter, control valve, and the rubber piping laid to the gas regulator. The inlet of water is in the side of top cover fixed with the control cork, and the heated water outlet is at the center of wooden top. The outlet is fixed with the metal cases, thermometer, and two-way valve. Now let us know the procedure, how to conduct the experiment and how to take the readings. So connect the gas burner inlet to the main source of the gas cylinder, supply through the pressure regulator and gas flow meter. Connect the circulating water inlet connection to source of water. Keep the inlet walls of water and gas closed before connections are made. Fix the outlet thermometer to water line. Allow then a water flow through the coil first. Lit the gas by opening the inlet valve. Adjust the regulator and valve so that sufficient flame appears. Now release the handles. Adjust the water flow so that sufficient temperature is read in the thermometer. This is only an arbitrary. For accuracy of calculation, the higher temperature and higher water flow rate readings are preferred. Note down the readings on the gas flow meter, which gives directly the amount of gas burnt per minute for heating known quantity of water through the known temperature. Different readings on the thermometer. After the experiment is over, close down the glass supply tightly and tabulate the results. So now here what we have been doing, so we are going to tabulate the following things in the tabular column. So note down the volume of flow rate of the water and volume of flow rate of the fluid, and temperature of water at inlet, temperature of water at outlet, and pressure gauge and calorific value of the fuel you can find out. The energy balance equation is being considered, neglecting the heat losses. So heat released by the gas you are going to calculate, then heat that will be equal to the heat acquired by the water. So by this you can find out the calorific value of the gas, whichever we have been considering here for the calculation.